Okay, welcome to the video. Now, as you should hopefully already be aware, the exam boards for the GCSE Maths 2022 exams are giving us the topics that are going to be on each paper. Now in this video we're going to be having a look at paper 1 and we're going to be focusing on the foundation paper. Now if you're sitting the higher paper, not to worry, the higher versions of this are going to be coming out as well, as will be the paper 2 and paper 3. So I'll be releasing one of these each day, so if you are doing the higher paper, just make sure you stay tuned, subscribe to the channel, and obviously you'll get the notifications when the higher paper versions of this are released in the coming days. Now if you are sitting the foundation paper, obviously this is going to be for your paper 1 exam, and all of the topics that are on that exam are on the screen. Now the document here will be available. I will put them linked into all the videos once all the videos are released, so as soon as they are all released you'll get access to all of these files as well, and you can obviously use this as a tick box or just an exercise to check off each of these topics as you go. So throughout this video what we are going to do is go over one version of a question to do with each of these topics. Now that obviously means, as I'm only going to be going over one version, that you will obviously have to do further revision and having a look at each of these topics in a little bit more depth, particularly the ones that you're not so sure about. And obviously you can do that using guidance from your teacher and from your revision guides, and as well you can obviously use the links in my video. Now if you've obviously been using this channel a lot, you'll know how my videos work, but if just in case this is the first time that you are seeing one of these videos, I'm just going to quickly show you how that works. So when you are on one of my videos, you can obviously click and have a look at different elements. Now if you pause the video, you'll see just in the bottom left of the video there, we've got the chapters. So if you click onto that to the side or down below, depending on what device you're using, you can have a look and you can scroll through and see all of the different topics, so you can flick through particular ones if that's how you'd like to use the video. Alternatively to that as well, you can click into the description, and if you scroll down there's lots of useful and helpful links there, but you can see that I put all of the timestamps in with their topic name and a link to a full lesson on that topic. So if you're not sure on one of the topics that you are watching currently on the video, you can obviously just go in, click onto the full lesson and have a look and learn everything about that topic. So hopefully that's really useful, hopefully it's helpful, and we're going to get started on this video because we've got a lot of topics to get through. But obviously if you find these videos useful and helpful, please do like the video, drop me a comment, let me know if there's anything that you'd like to see further put onto the channel that I can help you with, and obviously don't forget to subscribe. So with that being said, let's get started. Okay, so we're going to round these numbers to one significant figure. So 6.32 is going to round to 6, 6.51 rounds to 7, and then 0.503 to one significant figure on the bottom is 0.5. Now whenever we've got these, we've got to work out what's on the top and what's on the bottom. So on the top there, 6 times 7 is 42, and it's 42 divided by 0.5. Obviously if that was a nice little division there, we could do that straight away, but dividing by a half does something in particular. So dividing by half actually doubles your answer. If you think half fits into 1 twice, so it'll fit into 42 84 times. So there we go, dividing by 0.5 doubles our number. Obviously if we had something like 3 on the bottom or something like that, that'd be a little easier, but dividing by 0.5 doubles our answer. So that's estimating. Just remember to round to one significant figure and then to complete your sums that way whenever you see that word estimate. So write 180 as a product of prime factors and give your answer in index form. So we can do our nice little prime factor tree. And again, thinking of any two numbers that times to make 180. So I'm going to go for 18 and 10. 10 becomes 2 and 5, locking off those numbers when we see that they're prime. 18 is 2 and 9, and 9 is 3 and 3. And again, locking those all off when they're prime. Remembering you can write down some of the prime numbers if it helps. Now writing these in size order, we get 2 times 2 times 3 times 3 times 5, and then we can simplify these. So 2 times 2 becomes 2 squared, 3 times 3 becomes times 3 squared, and then times 5 at the end, and that's in index form there using index. Right, so a washing machine costs £640 plus 20% VAT. James pays a £68 deposit and the rest in 10 equal monthly instalments. Work out the cost of each monthly payment. So it's a percentage of an amount question, so we need to work out 20% of 640. 10% is the most important percentage we ever have to work out, so we can work out everything from there. So we'll work out 10%, 10% is £64. 20% will be double that. So double that is £128, so that's the extra amount he's got to pay for VAT. So if we add these together, 640, add 128, we get £768. Now it says he's going to pay a £68 deposit, so let's take that £68 off because that's what he pays right at the start, and that leaves us with £700. Now it says in the question he's going to pay that in 10 equal monthly instalments. So if we finish this off, if we divide this by 10, so 700 divided by 10 tells us that he's going to pay £70 per month. There you go. So the main part here was the working out the percentage. So always work out 10%, and remember from there you can figure out any percentage. We could have halved 10%, we could have got 5% as 32, or we could have actually divided it by 10, we could have got 1%, dividing 64 by 10, 1% would have been £6.40, and we could have built that up to any percentage that we wanted from there, so £6.40. Let's have a look at something else. Okay, moving on to fractions, multiplying and dividing fractions. Multiplying fractions is the easiest one, isn't it? So we can times the top numbers, 3 times 2 is 6, and times the bottom numbers, 4 times 3 is 12, and we always want to simplify our answer, and a question will normally ask us to write it in its simplest form. So here we can divide the top and bottom by 6, and we get 1 over 2 as our final answer there. So always looking to simplify. On to the next one. We keep the first fraction the same, we flip the second one over, and we multiply them together. So times in the top numbers just like before, 2 times 5 is 10, 1 times 9 is 9, and again we'd normally be asked to write our answer in its simplest form or as a mixed number, and here it is an improper fraction. 9 fits into 10 once, with a remainder of 1/9 left over, so 1 1/9 would be my final answer there, and that's dividing fractions. When it comes to adding and subtracting, the process is the same. I'm just going to go for this one addition. So when we're doing this, we need to obviously look at the fact that there is a mixed number here, and we're going to make that into an improper fraction first, and the same goes for multiplying and dividing. So we're going to do 1 times the 4, the big number times the bottom, and then add the top. So 1 times 4, add the 3 is 7 quarters. And we're going to add to that this 2/3, and again if that was a mixed number we'd also convert that into an improper fraction. Now we need a common denominator when we're adding and subtracting, so that's going to be 12 on the bottom, so we can times this left fraction top and bottom by 3, and we can times this right fraction on the top and bottom by 4, and that's going to give us 2 fractions out of 12, so 7 on the left times 3 is 21 over 12, and on the right 2 times 4 is 8 over 12. And now we can add these together, and again if we were subtracting them we'd just subtract those numerators now, but we'll add them together and we get 29 over 12. And again it says to give your answer as a mixed number, so we are going to convert this now into a mixed number. 12 fits into 29 twice up to 24, and there'll be a remainder of 5/12. And again there's my final answer. Just be very careful at this point just to have a look, does this fraction simplify here, the little one? It doesn't, but let's imagine it was 4/12 there instead of 5/12, that would actually simplify, wouldn't it? Because if it was 4/12 we could divide the top and bottom by 4, and that would end up being 1/3. So just have a look in that situation, does it simplify? This one obviously doesn't, it's 2 5/12. Let's have a look at another one. So in a bag of counters, 2/5 are blue, and it says 18 are blue. Work out the total number of counters in the bag. So it's not asking us to work out 2/5 of a number, it's saying that 2/5 are 18. Remember it could have said work out 2/5 of, let's say, 20, and you divide by the bottom to get 1/5, you'd say that 1/5 is 4, and then times by the top to get 2/5, and we'd get 2/5 would be 8. That's a different question, so it's nothing to do with that, but it says 2/5 are blue and 18 are blue, so 2/5 equals 18. So if I want to work out 1/5 in this scenario, I need to divide by the top this time, because that gives me 1/5, half of that, so 1/5 would be 9, and then to work out 5/5, the original amount, we could times that by 5, so times it by 5, and we would get 5/5 equaling 45 counters. There you go, so that's our scenario there. So slightly different the other way around, obviously, to working out a fraction of an amount. It says that that fraction is 18. So dividing it by 2 to get 1/5, and then timesing it by 5 to get the original amount. Okay, so writing some numbers in standard form. we're going to make this a number between 1 and 10 times 10 to the power of however many jumps we have to do in whatever particular direction. So this number here, 5,600, I'm going to hop the decimal in between the 5 and the 6. So 1, 2, 3. So that becomes 5.6 times 10 to the power of, it's a big number there, it's not a 0-point number, so 10 to the power of 3. Final answer. The next one is a small number, so we're going to have a negative power because we hopped the decimal the other way this time. So 1, 2, 3 would make it 3.4, and again this time it would be times 10 to the negative 3 because it's a 0-point number. That indicates that it's a small number. When it comes to the other way round, writing them as ordinary numbers, I like to rewrite this little bit at the start to start with. So 2 and 3, and I like to just imagine where that decimal is between the 2 and the 3. So times 10 to the power of 5 makes it a big number, so we need to hop it 5 places. 1, 2, 3, 4, 5 to the right, and then filling in all those zeros underneath. And if it is messy, just remember to rewrite that. But there's my answer, 230,000. The next one, 8.04 times 10 to the negative 3. So this is going to be a 0-point number. And again, I'm just going to write these digits out at the start, these bits here, and imagine where the decimal is at the top, 8.04. So negative 3 means it's going to be a small number, so we're going to jump it left 3. 1, 2, 3. So it's going to go there. Fill in all the zeros and tidy it up at the start. So 0.00804, final answer. Okay, so looking at this one, 4 times 10 to the 5 times 3 times 10 to the minus 2. And there's an example of one where we probably wouldn't want to write this out as ordinary numbers and work them out because it might get a little bit overcomplicated here. But let's look at applying that same little trick. So let's do the 4 times the 3, which gives us 12. And that's going to be times 10 to the power of something. I'm just going to be a little bit careful here because although we can add these powers, let's just have a look because one of them's a negative. So the powers, if I write this to the side, we're going to do 5, the first power, and we're going to add the next power, which is negative 2. And 5 plus negative 2 is 5 take away 2, so my power there is going to be 3. So that's fine, 12 times 10 to the power of 3. And again, we just need to put this in standard form because this 12 is not between 1 and 10. So instead we'll make that one jump smaller, we'll make it 1.2, and to balance that out we'll make the power one jump bigger, so 3 goes up to 4. And there's our final answer, 1.2 times 10 to the 4. Same process again. We've got 3 divided by 6 though. So let's do this to the side. 3 divided by 6, let's write that as a fraction. 3 divided by 6, if we simplify that, goes down to 1/2. So to keep this as a number rather than a fraction, I'm going to write that as 0.5. So over here we have 0.5 of 3 divided by 6, and then we've got that times 10 to the power of, and again subtracting the powers on these. So we've got 3 take away and negative 2 on the second one, and 3 take away negative 2 turns into a plus, so we have 3 plus 2, which gives us a power of 5 for this one. So we have 0.5 times 10 to the power of 5. And again, we can balance this out because it needs to be in standard form, but this time to make 0.5 between 1 and 10, we make it one place value bigger to make it 5. And if we make the number bigger, the opposite this time for the power, we make the power smaller. So 5 drops down to a 4. So 5 times 10 to the 4. So a similar process, but here we had to make the number bigger, so we made the power smaller. Okay, so this question here, we have got it in reverse. So it says write 35% as a decimal. So again, I'm going to write the percentage. I'm going to write it without the percent sign and just write the numbers 35. So to turn it back into a decimal, we just divide it by 100. So we hop the decimal back in 2 places, which would make it 0.35. Obviously, when we're writing a decimal though, if we have a decimal point at the start there, we do want to just tidy that up and put a 0 at the start. So it's 0.35. And there we go, that's writing it as a decimal. So very similar to our previous question. Now we want to write it as a fraction. It says write 35% as a fraction. Now of course this has already given it to us as 35%, so we can straight away put that as 35 per 100, or as a fraction 35 out of 100. And again, that is all we need to do in terms of writing it as a fraction. Again, this question though does say give your answer in its simplest form, so we need to spot what they both divide by. Now hopefully you can see that because one ends in a 5 and one ends in a 0, that they definitely both divide by 5. So we'll divide them by 5 to start with, and then we can always see if it divides any smaller. So 35 divided by 5 is 7. In fact, let's just swap back to our other colour there. 35 divided by 5 is 7, and 100 divided by 5, don't know why I put divided by 2 down there. We definitely wanted to divide by 5, but 100 divided by 5 is equal to 20. So we've got the answer 7 over 20. Again, the numerator there, 7 only divides by 1 or 7, and 20 doesn't divide by 7. Not perfectly anyway, and we are looking for a number that fits in perfectly. So our answers there was 0.35 for our decimal, and 7 over 20 as our simplified fraction. Okay, so it says here, write the following numbers in ascending order. Now ascending order means smallest to biggest. So we need to find out which of these is the smallest, which is the biggest, and put them in order. Of course, at the moment we have a decimal, we have a fraction, we have a percentage, another fraction, and another decimal. So it's not very nice to order them as they look. So the best thing to do on a question like this is to turn them all into the same format. Now, you might have noticed on the previous questions, but with all of them, we used percentages. So personal preference for me, I like to write them all as a percentage. So first of all, why don't we just try converting them all into a percentage? Of course, you could try something else here, but I do think the percentages are the much easier way in order to do this. So for the first one, 0.30, and of course, don't forget you can put a 0 at the end there, because then when we multiply that by 100, it gives us 30%. So our first one is 30%. For the second one, we want to turn that into a fraction over 100. Of course, if you just know this already, then that is fine, but 1 over 4 would become 25 over 100. So that one there is 25%. Of course, if you just know that, that's fine as well. You don't have to show the working out for that as long as you're confident with it. Now the third one is already written as a percentage, so that's nice and easy, 28%. The next one's a fraction. So again, let's think about how we would turn that into a percentage. 6 over 25, we would want to multiply the top and bottom by 4 to make it over 100, and 6 times 4 is 24. So that becomes 24%. And then for our final question here, or our final part of this question, we've got a decimal. So if we times that by 100 and we hop the decimal, it's going to jump over the 9. So that is going to become 29.5. And there's our first part where we've had a decimal inside our percentage. But that's fine as well, it's just 29.5%. So let's get rid of our working out and then let's think about which one of these is the smallest, and then we'll put them in order. Now when you're doing this question, it says write the following numbers in order. It doesn't say to write these percentages in order. So we do have to write the original parts of the question in the appropriate order. But before we do that, I'm going to order them from the smallest. So hopefully you can spot 24% is our first smallest number. We then have 25%, which is our second. Then we have 28%. Then we have 30%. And then actually, I've missed out the 29.5. Our fourth smallest was definitely the 29.5%. And then we have our 30%. So as you've just seen, always be very careful and check that you've read all the numbers carefully. So now we've got that done, let's just write the original parts in order. So the first one was the 24%, and that was 6 over 25. The next one was the 25%, and that was 1 over 4. The next one was 28%, and that was already a percentage, so that's fine to leave it. The next one was the 29.5%, which is 0.295. And the final and biggest part was the 0.3. And there we go, we've written them all in ascending order using our conversions. Okay, so we're looking at some negative numbers. Now it says here at 7 AM the temperature was -4 degrees. It says by 3 PM the temperature had gone up by 10 degrees. Write down the temperature at 3 PM. So in order to do this, we're going to first bridge 0. So what I mean by that is, what do we have to add to -4 to get to 0? That's going to be 4, and then we've got an additional 6 to add on. So the calculation we're actually doing here is -4 add 10. You might be quite happy just doing that, but we've got to add 4 to get to 0, then an additional 6, and we do get to 6 degrees Celsius. So there we go, that would be our answer for that, 6 degrees. For the second part of this question, it says at 9 PM the temperature was -2 degrees, and by midnight the temperature had gone down by 7. So the calculation we're doing here is -2 as our starting position. We're going to take away 7 as it's going down by 7. So -2 take away 7 would get us down to -9 degrees, and that would be our final answer. So this is obviously just looking at adding and subtracting when we have negative numbers involved. Not forgetting, and this is something that people tend to get wrong, just because there are 2 negatives in this question, that does not mean that it becomes a positive. That rule only applies when you have two negatives next to each other. So if I was to create a completely different question, I could have something like 3 take away negative 5. Now this is the scenario when they are right next to each other, whereby they turn into a plus. So that would become 3 plus 5, which equals 8. So this is the one scenario where it happens, and of course when you are multiplying with negatives, so something like negative 3 multiplied by negative 5 would become positive 15. So these are the scenarios where two negatives do end up or result in a positive answer, but it certainly doesn't apply when we have a negative number as our starting point and we are simply taking away. So obviously don't forget that when it comes to negative numbers. Obviously sidetrack from the question slightly there, but hopefully that's going to help as a little reminder when you're dealing with negatives. Okay, so moving on to algebra, and we're looking at index laws to start with. So we know with index laws, we've looked at this when we have powers that are getting multiplied together when they have the same base number. These powers can be added together, so 2 and 3 would make 5. We also had the process when they're being divided, so x to the power of 7 divided by x squared, we take away the powers and we get x to the power of 5. And we also have powers in brackets, so if we have x squared to the power of 5, we multiply the powers, so we get x to the power of 10 in that particular example. Now having a look at this one, we've got 30x squared y to the power of 3 on the top and 6xy squared on the bottom. So we're doing a divide. Now we've got these numbers on the top and the bottom, 30 on the top, 6 on the bottom. So numbers always just divide numbers, so 30 divided by 6 gives us 5. Now individually looking at the letters, we've got an x squared, and on the bottom we've got an x. Now it's not written in there, but that is a little power of 1 there that's not written. So if we subtract the powers, 2 take away 1 gives us x to the power of 1. I'm not going to write that in, I'm just going to leave it as x because that means x to the power of 1. Moving on to the y's, we have y to the power of 3, y squared on the bottom, and 3 take away 2 gives us just y on the bottom there. So our final answer would be 5xy. Okay. Looking at this one then, we've got powers in brackets, so we're going to be multiplying powers here. But we've got this number 2 in the start as well, so numbers always get treated like numbers, and that whole thing is being cubed. So we need to work out what 2 cubed is. 2 cubed is 2 times 2 times 2, which is 8. So we're going to have 8 at the start of this one. Multiplying the powers for the x then, x to the power of 2, that's going to get times by 3, so that's going to become x to the power of 6. And y there is a power of 1 which is not written, so 1 times 3 gives us y to the power of 3. And there's our final answer there. So a equals 5b plus 2c, b equals 3 and y equals negative 2, find the value of a. So we're just having to substitute these numbers in. So we're going to find out what a is. So a is going to equal 5 lots of b, and when I sub a number in I always put it into a bracket, so we have 5 lots of b, which is 5 lots of 3, and then 2 lots of c, so plus 2 lots of negative 2. We put these in a bracket like that. All we have to do is now multiply these. So 5 times 3 is 15. 2 lots of negative 2 is negative 4. And we're adding these together. So 15 add negative 4 is 11. Remembering that these just become a takeaway. So it's 15 take away 4. So a would equal 11. There you go. Just something to remember there. Whenever you're subbing numbers in, always put them into a bracket there, just so that you can sub them in and then deal with the calculations later. Okay, so on the number line, show this inequality. So when we're drawing these sorts of things on a number line, we look at what numbers we've got. We're going to put our little circles above those, so negative 2 and 4. And we're going to join them up. And then we just need to have a look at these symbols. So the 1 here, which is less than or equal to, or pointing towards that less than or equal to, it has more ink on it, so we just remember to colour that one in. Make sure the circle has more ink in there as well. Nice little way of remembering it. There we go. So that is between -2 and 4. Remembering that is equal to -2, so the numbers that this could be is we could have -2, -1, 0, 1, 2, and 3, but not including the 4 there because it says less than 4. So you can have an inequality like this as well, where it just says x is greater than or equal to 1. So again, putting our circle above the 1, the greater than or equal to has the extra ink on it, so we'll colour that one in. It's equal to that as well, and greater than 1, so we'll just point an arrow to the right saying it's got to be greater than 1. And that's that for that type of inequality. Okay, so a nice quick one here, solving an inequality. Now this symbol shouldn't put you off here. It's an inequality, yes, but we're going to treat it exactly the same as if it was an equal sign. So before we saw a question like this where it was 2x plus 3 equals 20. We're going to do it in exactly the same way, but we're just going to leave that symbol in there. So we're going to take away 3 from both sides, which leaves us with 2x is less than 17, and then dividing by 2. we get x is less than 17 over 2, and we could probably work that out. 17 over 2, half of 17 is 8.5, so x is less than 8.5. Okay, so on to factorising a quadratic. This is the opposite of expanding a double bracket, so we know what our answer is going to look like already. It's going to be in a double bracket, both with an x at the start. Now when we're doing this, we've just got to find the pair of numbers that are going to go into our bracket. So looking at the 12, we know it's going to be a pair of numbers that multiply to make 12. So I always write these down. We can have 1 and 12, 2 and 6, or 3 and 4. Now we just need to have a look at these numbers there, because we've got a 7x in the middle, so they have to add up to make 7x. So 1 and 12, there's no way I can make 7. 2 and 6, I could either make 8 by adding them together, or I could make 4 or minus 4 if I do a minus with one of them. So I'm not going to make 7, but I can make it with 3 and 4. I can have plus 3 and plus 4, and that would make 7. So plus 3 and plus 4, and that's not a 4, plus 3 and plus 4, and that would be factorised. Having a look at the one below, we've got some negative symbols going on there, so we've got a slightly different process, but our answer is going to look the same. It's still going to be in a double bracket, it's still going to be x at the start, and we're still going to have two numbers in here with some symbols. So 28, the numbers at times to make 28 are 1 and 28, 2 and 14, or what else could we have? 4 and 7, and let's have a look if these can make 28. So what have we got? We've got minus 3 in the middle. So we want to make minus 3. Well, we're not going to do that with 1 and 28. That's not going to work. 2 and 14, we could make 16, or we could make 12. That's not going to work. But 4 and 7, we could do plus 4, take away 7. That'd make minus 3. So plus 4 and negative 7. And that's our double bracket there finished. So when it comes to solving a quadratic, the way to solve it is we have to factorise it. And we can only factorise it, and we'll discuss this a little bit more, when it is equal to 0. So sometimes they won't be equal to 0, but particularly in the foundation level style questions, they're always going to be equal to 0 here. And if they're not, we'll have a look at how to obviously just rearrange them slightly in a later question here. But when it comes to this here, all we're going to do is we're going to have a look at that quadratic there. So we've got x squared plus 7x plus 12. Now when we're factorising one of these, they go into a double bracket. And all we need to do is have a look at this number at the end, which is 12, and we have a look at what numbers multiply to make 12. So we could have 1 and 12, and again I'm not going to talk about this too much because I'm going to link the description for factorising quadratics, but we can have 6 and 2, and we can have 3 and 4. So we just need to figure out what combination of numbers are going to go into our double bracket. So we'll put our double bracket here, it's all equal to 0, and we've got an x at the start of both brackets. So obviously we're looking at that number in the middle there, the coefficient of x, which is positive 7. So the two numbers that are multiplied to make 12 and also add to make that positive 7 are our 3 and our 4. Okay, so we're going to put 3 and 4 in our bracket, and that would be plus 3 and plus 4. There we go. Now in terms of obviously our solutions here, now you don't really need to know this for this question in particular, but if this was a quadratic equation, a line equation, sorry, it would relate to a quadratic curve. Okay, now I'm going to draw what this would look like. It looks something like this. Okay, there we go, not to scale there, but it looks something like that. Now when we are looking at the solutions here, we are looking for essentially where this curve crosses through the x-axis, and that's what equal to 0 is representing there, and it's in a kind of very simple level. Equal to 0 kind of means ground level. It means where y is equal to 0, and if you think about the y-axis, the y coordinate just here, we've got y equals 0 just down there. So we are having a look at, on this graph, where does the quadratic curve cross through the x-axis when y is equal to 0. Now there's a little trick with these brackets, but in terms of obviously explaining how we go about getting our solutions here, we just say, okay, well when does this bracket here, x plus 3 equal 0? And if we write that out, when does x plus 3 equal 0? And if we take away 3 from both sides to solve that, we get x has to be equal to negative 3. And if we do that for the other one as well, so if we do that for this one just here, we say, okay, well when does x plus 4 equal 0? And again, if we solve that and take away 4 from both sides, we get x has got to be equal to negative 4. So there we go. If I label that on the graph here, we've got minus 3 and we've got minus 4, and that's how I knew what the graph would look like. But there we go, there's our two solutions, x is negative 3 and x is negative 4. But if you have a look at the bits in the brackets there, obviously we've got a plus 3 in the bracket, and our solution ended up being negative 3. And on the flip side, on the other one, we had plus 4 in the bracket, and our solution ended up being negative 4. So obviously it's important to know how to do this little process here, setting them both equal to 0 and solving it for some of the harder ones. But in terms of just getting through these questions nice and quick, once you've factorised it, all you have to do is flip the symbol in the bracket there. And we're going to have a look at a couple of others where maybe there's a negative in the bracket or two negatives or something like that. But that's all you've got to do is just flip the symbol. So there we go, there's our two solutions. X is equal to -3 and X is equal to -4. So you will notice that in these questions we'll tend to get two solutions, unless obviously the two solutions are maybe the same, which can happen as well. But we're always going to get two solutions here. And in this case, it was -3 and -4. Slightly different one, so draw the graph of y equals x squared plus 2x minus 3 between -3 and 2. Now again, I'm going to do a little table for this. So we have x and y, and it's between -3 and 2. So -3, -2, -1, 0, 1, 2. Now this is a slightly more complicated one for us to sub in, because to find the y coordinate you have to do x squared, add 2x, take away 3. So I want to write these down nice and carefully. So I'm going to start with 2 again for the positive one. So we have 2 squared plus 2 lots of 2, take away 3. I'm just going to work that out nice and slowly. 2 squared is 4 plus 2 lots of 2, which is 4, take away 3. So 4 plus 4 is 8, take away 3 is 5. So my answer there underneath the 2 is going to be 5. Now I need to follow this process for all of them, but the one thing I do need to be careful of is when we get to these negative numbers. So up here where I put 2 squared in, just here, we should really make sure we keep that in a bracket, because as we get down to those negatives it's going to have a big effect on that, and we'll see what happens when we get to them. Now I'm going to do the other ones a little bit quicker. Let's have a look. So 1 squared is 1, add 2 is 3, take away 3 is 0. 0 squared is 0, add 0 is still 0, take away 3 is -3. And here's where we need to be careful. So the first one here is -1. So I need to put, if I'm going to do this on a calculator, I'll write my working out down. -1 squared, add 2 lots of -1, and then take away 3. Now the reason you have to put this in a calculator is because if you put -1 squared without the brackets, it will give you the answer -1. It will square the 1 and put the negative with it, rather than doing -1 times -1. Squaring a negative number makes it positive, so -1 squared is 1, add 2 times -1 is -2, and take away 3. So 1 take away 2 is -1, take away 3 is -4, so we get -4 for that one. Okay. Let's have a look at the next one. -2 squared is 4, add -4 is going to be 0, and then take away 3 gives us -3 again, and then onto the -3. -3 squared is 9, add 2 lots of that, so -6, so 9 take away 6 is 3, and then take away 3 again gives us 0. So you can probably see a little bit of a pattern here. Look, if you look at that -4 in the middle, either side of that we've got -3, either side of that we have 0, and then we have the additional 5 there. But let's just plot these and see what it looks like. So -3 to 0 is there, -2 to -3 is there, -1 to -4 is here, 0 to -3, 1 to 0, and 2 to 5, which is all the way up there. There we go. So this forms a quadratic curve, a parabola, and we just need to draw that with a nice smooth curve as best you can, going through all the points, making a nice smooth curve. And there's our graph drawn. Just as a note, we could also have a cubic graph. So we could have an x cubed up here, and we just treat that in exactly the same way, subbing the numbers in very carefully using brackets. And it tends to be that a cubic graph has this sort of shape, so just be careful. There are some others as well. We could have a reciprocal graph, where we have something like y equals 3 over x, and that has a different look again. It has this sort of curved shape within the positive part of the graph. So there's lots of different graphs that we can have a look at, but just treat it all in the same way and plot the points very carefully, joining them up with nice smooth curves. So find an expression in terms of n for this sequence. So we're going to do the nth term, and then it says hence find the 50th term. So what I always like to do is draw these little loops just to see what times table this is related to, and from 3 to 7 it goes up by 4, and then it keeps going up by 4. So this is related to the 4 times table. Now the expression for the 4 times table is 4n, if we do it in terms of n. Now this is obviously not the 4 times table though, is it? Because the 4 times table, if I write it above, is 4, 8, 12, 16, 20. And all of these numbers are 1 less. Look, from 4 to 3 is -1, from 8 to 7 is -1, so it's the 4 times table but it's had 1 taken away, and that is our nth term there in terms of n. There is also a little trick that you can apply on this. You can go backwards 4, so if we go back 4, we get the number -1, and that always tells us how much smaller or how much bigger it is than the times table we're looking at. So it says hence find the 50th term. Well, here's our little code, 4n-1. To find the 50th term in the 4 times table, you do 4 times 50, and it's no different for this one, but it's the 4 times table take away 1. So we're going to sub it in, and we get 4 times 50, or 4 lots of 50, but then we have to take away 1. 4 lots of 50 is 200, and 200 take away 1 gives us 199, and that is our 50th term. Just thinking, if you didn't have this nth term, you'd have to just keep counting up from 19, so you'd go 23, 27 and so on, and you'd have to keep counting up to the 50th term, and it'd take you quite a long time, so this is a nice little shortcut for that. Okay, so when it comes to length conversions, there's a few things that we need to know. So one thing that we need to know is that 1 centimetre is equal to 10 millimetres. Okay, and a lot of these things you can see on your ruler, but obviously not when it comes to centimetres to metres. When it comes to centimetres to metres, we need to know that 100 centimetres is equal to 1 metre, or we could say that 1 metre is equal to 100 centimetres. So obviously we need to know these. You can also need to know kilometres as well, and for that we need to know that 1 kilometre is equal to 1,000 metres. So you could obviously have questions on any of these conversions, but if we look at these 2 that we've got here, for starters we've got change 350 centimetres into metres. Well, there are 100 centimetres in every 1 metre, so if we divide this by 100, that would just mean hopping the decimal in 2 places, and we would get 3.5 metres. So that's one conversion that we could have. This one's a little bit harder. We've got 8.3 metres into millimetres, and you'll also notice that in the first question the actual units were given to us in words, and here they're just given to us as m and double M there for millimetres. So we could have either of those, but for this one it's a little bit trickier because we're going from metres, which is in this conversion here, down to millimetres, which is in this conversion here. Now you can always learn the conversion between the two, but I think it's easier here to first convert it into centimetres and then convert it into millimetres. So to convert it into centimetres, we would want to multiply the 8.3 by 100, as there are 100 centimetres in every metre. So 8.3 multiplied by 100 just means hopping the decimal over the 3 and then over again, which would make it 830. So it's going to be 830 centimetres. Now every centimetre has 10 millimetres in it, so we're going to multiply that by 10 to convert it into millimetres. So we'd write 830 multiplied by 10, and obviously just adds a 0 on the end there, so that's just going to be 8,300, and that is millimetres. And there we go, that would be our final answer. I would obviously just take the same approach if we had kilometres involved, so we would divide or multiply by 1,000 to turn the kilometres into metres or the metres into kilometres. And there we go, there are some of our length conversions. Okay, so working out 45% of 64. It's a little trickier here because it doesn't end in a 0, but just straight away let's think about our process. So we're going to work out 10% straight away, and we'll work that out in just a second. We're also going to need 5%, so we'll have to work that out as well, which again we'll work out in just a second. And then we're going to need to get to 45%. So in terms of what I'm going to actually need here, I'm going to need 4 lots of the 10% and 1 of the 5%. 4 lots of 10 would be 40%, 1 of the 5s is 5%, so combined there, that's going to give us our 45%. So let's work out our 10%. Now we've got 64, so to get 10%, divide it by 10, so hop the decimal in, and we get 6.4. So our 10% here is going to be 6.4. And again, we're going to want to halve that for 5%. And again, if you are struggling to halve these numbers at any point, don't forget you can always just divide it by 2 using bus stop just to the side if you need to. 2 goes into 6 3 times, keep your decimal point in place, and 2 goes into 4 twice, so 3.2. And there we go, 5% is going to equal 3.2. So we want 4 of those 6.4s and we want 1 of the 3.2s. And now again, you could multiply 6.4 by 4, or you could just add them all together using column addition. So we want 4 of those. Again, if we go beyond 40%, you've probably got quite a few there, and you probably want to multiply them instead. But not too difficult for us to just add those together. So what do we get? 4, 8, 12, 16 plus the 2 is 18, so carry the 1. and then 6, 12, 18, 24, 27, plus the 1 is 28, so we get 28.8, and there we go, there is our final answer, and that is 45% of 64. Again, just being very careful when you do that. Obviously I've added them together quite quickly, so take your time with it, but just as I said before as well, you could actually have just done 6.4 and multiplied it by 4 instead if you prefer to use a multiplication method. But if you are going to do that, don't forget to take the decimal out before you multiply, so we would have instead done 64 times 4 and then hopped the decimal in at the end and then added the extra 3.2. So arguably that might be a little bit longer than just adding it together. I think if you just add them together, it's pretty quick and everybody's normally pretty happy to do column addition. So if we want to get this without a calculator, all that we actually have to do is follow our process for working out a percentage, and that is to obviously start by working out 10%. So work out 10%, which is 12, and for 20% we can double that, so 20% would be 24. And then we're obviously increasing by a percentage, so we would increase by this 24, so we just add that onto the 120. So 120, add 24, and that comes out as 144. So we know the answer is 144, so for this type of question, why would we bother using a multiplier? Well, to be fair, for this type of question, we probably wouldn't. It'd probably be quicker for us just to work it out without a calculator, but not all questions are going to be this simple, and not all percentages are going to be as simple as 20%. So we need to have a method for if it's going to be a little bit trickier, surely there must be a faster way for us to do this with a calculator, and there is. So we're going to look at that 20%, and we're going to figure out what we would actually multiply by to increase by 20%, and therefore, you know, if it was 17% or 5%, what would we actually be able to multiply by? And it all comes down to thinking about that as a percentage more than the original. So the original amount that we have, we could think about as being 100%, and I'm going to draw it as a little bar. So we've got 100%, and we are going to add on an extra 20%. So that's almost like we're extending the bar, we're making it 20% bigger. Now, if we think about that, what is that as an overall percentage? Well, we've got 100% and we've got 20% there, and overall that is 120%. And if we want to increase by 20% to get this 120%, we need to think about what 120% is written as a decimal. Well, 100% isn't actually written as a decimal, that would just be the number 1. So the 100% would be written as the number 1, but what would go after the 1? So it'd be 1 point something. Well, thankfully, it just reads as it does just above. It's 1.20. So that 0.20 there is the extra 20% on top of the 1, which is our 100%. So it's the extra 20% on top of the 100%. And that right there is the decimal that we would need to multiply by. We would just multiply by 1.20. Obviously, you don't need to put the 0 at the end, so you would just multiply by 1.2. And 1.2 is the decimal multiplier to increase by 20%. And if you get your calculator now, because we're obviously using a calculator method, and you type in 120 and you multiply it by 1.2, then you will get the 144. So let's type that in, 120, multiply it by 1.2, and in this instance we actually do get 144. So you can see it actually calculates that percentage increase for you. So obviously, when we are using a calculator method, we need to know a few things here. We need to know obviously how to turn the percentage into the decimal, and obviously thinking about the fact that it has to be 1 point and then that increase in that decimal there. So another example that we could think about is, let's say we were increasing by, and let's go with 30%. So what would an increase of 30% be? Well, instead of being 1.2 or 1.20, instead it would be 1.30. And it just follows on this little pattern. So you don't have to write down the full 120% and draw the bars. All you have to know is that if you are increasing by a percentage, it's 1 point, and then whatever that percentage is afterwards. So in the case of 20, 1.20, in the case of 30, 1.30, and that's what we'll multiply by. Okay, so this question says, Alice buys a pack of 10 drinks for £4. She sells all 10 drinks for 50p each. Work out Alice's percentage profit. Well, her original cost then is £4, so we've already spent the £4 on our 10 drinks. She's then going to sell them all for 50p, so we need to do 10 times 50p. So 10 times 50p, and again you can work that out however you choose, but that comes out as 500 pence. There we go. And we will probably want to convert that into pounds because the other one's already in pounds. Although we could change the £4 into 400p. I'm just going to turn this into £5. There we go. So now we can actually work out how much profit that she's made, because she's bought them for £4, sold them for £5. So she is going to make £1 profit. And there we go. And now we've got our £1 profit. We can just apply that to this question, just like we have on all the others. So the profit is 1 and the original was 4. So we can do £1 out of 4, which straight away comes out as 1/4. So that's a very nice one for us because that is straight away going to be 25%. Of course, if you want to multiply that to make sure we get the right number on the bottom, you multiply by 25 to make it 100. That's not drawn that 25 very nicely. Let's write that carefully. There we go, times it by 25, and you'll get 100 on the bottom, and you get 25 on the top, which is 25%. And there we go, there's our final answer. Again, you could work out that percentage of the original. 10% of £4, obviously you get into decimals here, but 10% of £4 would be 40 pence. We're trying to get to £1 profit, so we'd probably also want to get the 5%, so 5% would be 20p, and then we can build that together. We could add another 10% in, which is another 40p, and in total that now makes £1, and the total percentage there was 25% when you add those three together. So there we go, that is obviously approaching one of these problems. We had a little bit of working out to start with. Let's have a look at one that's slightly trickier than this then before you have a go at your final questions. Okay, so share £240 in the ratio 5 to 7. So if we're splitting this in a ratio, let's have a look. We've got in total here 5 plus 7 equals 12 parts. Okay, so if we split this into 12 parts, we could do 240 and divided by 12. And 240 divided by 12 is 20. So in each part there's £20. Now there was 5 parts and 7 parts, so those 5 parts are going to be 5 lots of 20, which would be £100, and the other part there was 7 parts, and that times 20 would give us £140. So splitting it in the ratio 5 to 7 gives us 100 to 140. And the last little check you can do here is just to add these two together, just to make sure you do get that £240 that you started with. So we're happy with that as a final answer. So Craig and Ian share some money in the ratio 8 to 3. Craig receives £32. How much does Ian receive? Well, C to I, Craig to Ian, was in the ratio 8 to 3. And it said that Craig receives £32. So that is this first number 8 here, that is 32. So what we've got to think about is how do we get from 8 to 32? So 32 divided by 8, which we can do to the side, 32 divided by 8 is 4. So we must have times by 4 to get there. So if we do the same to the other side, times by 4, 3 times 4 is 12. So there we go. How much does Ian receive? Ian receives this 12. So I'll just say £12. Final answer. So Emily and James share some money in the ratio 4 to 7. James receives £21 more than Emily. How much do they share between them? So Emily to James is in the ratio 4 to 7. Now it says that James receives £21 more, and if we look at these two numbers here, from 4 to 7 is an extra 3 parts. There you go, it's an extra 3. So that extra £21 is 3 parts. So if 3 parts of this ratio equals £21, then 1 part must be, to divide that by 3, must be £7. And from there we can work out how much they both receive. If it was 4 to 7, let's get rid of this little bit down here. And each part is now worth £7. Well, 4 times 7 gives us £28 for Emily, and 7 times 7 gives us £49 for James. So Emily receives 28 and James receives 49. It says how much do they share between them. So if we can add these together, it gives us the total amount. So 49 plus 28 gives us 7 and 7, so £77. There we go. So they share £77 between them. 3 tins of beans and 4 jars of jam weigh 2,080 grams, and the total weight of 5 tins of beans is 1,800. Work out the weight of 1 tin of beans and 1 jar of jam. Well, straight away we can work out the weight of 1 tin of beans from this, because it says 5 tins of beans is 1,800. So if we do 1,800 and divide it by 5, we get the answer 360. There we go. We might have to do a bit of bus stop for that, but we can do that. 5's into 1,800. 5 into 18 goes 3, remainder 3. 5's into 30 goes 6, and then 0, so 360 grams, and that is for the tin of beans. So tin of beans. There we go. It then says 3 tins of beans and 4 jars of jam weigh 2,080 back in the first line. So if we work out the weight of 3 tins of beans now, well, 3 of those would be 360, 360 and 360. If we add those all up, we get 9, 10, 1,080. So that's the weight of those tins of beans. So if we subtract that away from this original amount, so 2,080 take away 1,080, that leaves us with 1,000 grams. So those 4 jars of jam, so 4 jars equals 1,000 grams. And we want to know the cost of 1, so we can divide that by 4, and it gives us 1 jar equaling 250 grams. So there we go, 1 jar is 250 and 1 tin of beans was 360. So a car has to travel 30 miles along a motorway in 24 minutes. Will the car have to travel faster than 70 miles an hour to get there in 24 minutes? Now I'm going to do this as a non-calculator one, then we'll have a look at one that's maybe a little bit more calculator based. But if it has to travel at 70 miles an hour or more, now 70 miles an hour means that we go 70 miles in 60 minutes. So 70 miles equals 60 minutes. Now what we can do is we can actually start to break this down. So if I have a look, what can I divide both sides by? So if I can divide both sides by 10, that would mean I would go 7 miles in 6 minutes. Okay, dividing that by 10 as well. So you can have a look to see if you can ever break these down this way. So 60 divided by 10 gives us 6 minutes. There we go. Now it says we've got to go 30 miles and we've got to go there in 24 minutes. Now just having a look at this speed here, 7 miles equals 6 minutes. So travelling at this speed, if I wanted to get to 24 minutes, have a look, 24 minutes, we would times that by 4. So if I do the same to the other side and times that by 4, that gives us 28 miles. So travelling at 70 miles an hour, in 24 minutes we would go 28 miles, and the question said a car has to travel 30 miles, so it's not actually going to be able to make that 30 miles in 24 minutes. It's only going to be able to go 28 miles. It would have to go over 70 miles an hour, so I would make obviously that statement no. Okay, it's only going to go 28 miles, or it's not going to be able to do it in that sort of speed. Okay, so as you can see, this particular graph is incomplete, so let's have a read and see about how we're going to complete this. It says here is part of Carl's journey from his house and back. Here is the distance time graph for part of his journey, and it says part of his journey because it's not been completed. So for part A, it says work out Carl's speed for the first 30 minutes of his journey. So we need to be careful again because that's not necessarily the entire line there, but in this case I do think that is going to be the full line, as 30 minutes takes us up to this point. So that is for his full journey. So we're looking at the speed from the start of the journey, which is down here, up to the top of the journey where the other mark is. So obviously in order to work out speed, we're going to want to use our speed distance time formula, which again we'll write down in a formula triangle, and that is going to be speed is equal to distance divided by time. So we need a distance and we need a time. And again, we're going to write this in kilometers per hour, although it doesn't actually say to, so we could actually write this in kilometers per minute. But we're going to assume for all of these speeds, it's going to want it in that format. So in terms of the distance, that is a distance of 20 kilometers, which we can obviously read by looking just to the left here. So we have 20 kilometers as our distance, and we're going to divide that by, and let's just write it down here so we don't forget that number. It's 20 divided by the amount of time. Now again, this amount of time, as we've been told in the question, was 30 minutes. So if we're going to write that in terms of kilometers per hour, then we're going to divide that by 0.5. Again, converting those minutes by doing 30 out of 60 and spotting that that's a half, or typing it into your calculator. So 20 divided by 0.5, and again we can type this in on the calculator, it comes out as 40. A half fits into 1 twice, and therefore it doubles your answer, so it fits into 20 40 times. So just a quick way of dividing by a half if you don't have your calculator on you. So that's our answer for part A, and again that was in kilometres per hour. So we could write that as kilometres per hour. On to part B here, it says Carl spends 15 minutes at the shops, and we can see that on part of the journey. So if we get rid of this, we'll highlight that point, and as you can see, he spends 15 minutes. You can see that each of those squares is 5 minutes down the bottom, so we're happy with that. That is completed as being the 15 minutes. It says he then travels back to his house at 60 kilometres per hour, and to complete the travel graph. So actually what do we need to find here? Well, we need to find the time it takes him so we know exactly what time it's going to finish. For example, down here, we're at 45 minutes. Now if it takes him 10 minutes to get home, he would finish here at 55. And we could connect our line using a pencil and a ruler and complete our distance time graph. But we actually want to figure out the exact time there. So at the moment we're at 45 minutes, but how are we going to figure out the time? Well, it again comes back to our speed distance time formula. And you can see if you look just at the top here, that if we cover up time, then time is going to be working out by distance over speed. So we want to get the distance and divide it by the speed. And that's quite good because we've been given the speed in the question and the distance we already know because we've got it over here, it's 20 kilometres from his house. So we need to do the distance, which is 20, and this is for part B. And we're going to divide that by the speed, which is 60. So 20 divided by 60. And if we do 20 divided by 60, what answer do we get? Well, 20 divided by 60 is going to come out as a third. So how are we going to interpret that in terms of a time? Because that is in hours. So 20 divided by 60 comes out as 1/3. Now, this is the difficult part for these questions because you have to remember that that is in hours and we want it in minutes. So what is 1/3 of an hour? Well, 1/3 of an hour we can work out. We could do that and we can do the working out to the side because we've got 60 that we want 1/3 of. And 1/3 of 60 you can work out in two different ways. Either you could just straight away times that by 60 on your calculator. So just type in times 60 once you've got your third value and it will come out as 20. Or you could actually work it out using a fraction of an amount and you could do 60 divided by 3. Again, that comes out as 20. So the working out here, we want to get a distance there that ends after 20 minutes. So at the moment we're at 45 minutes and 20 minutes on top of that is going to take us to 65 minutes. And again, you could write that down. I'm just going to write down that it was equal to 20 minutes. So we have the working out down because you always want to make sure you show your working out for these questions. So again, you want to get your pencil and a ruler and you just want to connect that up using a nice straight line. And that would complete this distance time graph. Now you don't have to get rid of all of your working, but just make sure that that doesn't get confused with any of the other lines. You don't want lots of lines drawn on there as it might get confused with the actual line that completes the graph. So there we go, that would be how we would complete our graph. Now obviously the difficult part on this question was that completion part. So let's just run over that again. So we spend 15 minutes at the shops and then travel back at 60 kilometers per hour. So we took the distance, which we got from our formula triangle, and we divided it by speed. 20 was our distance from home, 60 was our speed given to us in the question, and that came out as 1/3. That was in hours, so we multiplied it by 60 because there are 60 minutes in an hour, and it gave us our 20 minutes. Because down the bottom it was in minutes, that allowed us to then draw 20 minutes on top of our 45 minutes, which allowed us to complete the graph. So hopefully you're okay with that. Obviously this is the most difficult part of it, so it was worth talking about that again. Okay, so this is quite an interesting question because this is talking about density, and obviously we're doing this non-calculator. And normally density is a calculator-based question, so hopefully we're going to have some nice numbers. Now as soon as you see that word density in a question, you're going to want to write down your formula, whether you use a formula or whether you use a formula triangle. So I'll write down the formula triangle because that works for everybody then. So that's going to be density is equal to mass divided by volume. Now this question says it wants us to work out the mass. So straight away, if I cover up the mass, that means I'm going to do density and multiply it by my volume. So this question gives us a cube and it says the rubber cube has side lengths of 4 centimetres. So in regards to this image here, we've got 4 centimetres across there, 4 centimetres here and a 4 centimetre height. So to work out the volume of a cube, you would just multiply all those numbers together, or in other words, 4 times 4 times 4. Obviously take that in stages. 4 times 4 is 16, times that by 4 again, and that is going to be 64. So 64, and the units are centimetres, so it's 64 centimetres cubed. Now it gives us the density. It says the density is 1.5, so we know to do this we do the density 1.5 and multiply that by the volume, and the volume is 64. So we just need to do 1.5 times 64, which isn't too bad. When you are multiplying by 1.5, that just adds on an extra half. Obviously you can hop the decimal out, you could do the working out to the side. So if we do that, we'll get 64 times 15, 5 times 4 is 20, 5 times 6 is 30, add the 2 is 32. Put our placeholder in, 1 times 4 and 1 times 6 is nice and easy. And if we add that together, 0, 6 and 9, so you get 960, and then you just have to hop the decimal back in one jump as we took it out at the start. So when you jump that in, you get 96.0, so that would be 96, and in the units it said grams per centimetre cubed, so that would be 96 grams as our final answer. So there we go, we'll get 96 grams. So as you can see, we can have density questions that are non-calculator, but you're going to tend to get nicer decimals involved. They're just going to be a little bit nicer for your calculations. Okay, so reflect the shape in the line x equals 1. Now this is your x-axis and this is your y-axis, so x equals 1 is right there. And the only line that you can do from that point, other than going across the x-axis, and it doesn't say the x-axis, is to go up and down. So x equals 1 is this line here. If you think about any coordinates on that line, the x coordinate's always 1. So that's our reflection line there. Now we're going to reflect it in that line, which is quite nice and easy to do. Pick a point, and we go 1, 2 to the line, so 1, 2 away, and just follow that process for all the points. So picking this point, that is 4 away, so another 4 away gets me to there, and the same one at the top, that's 4 away, and 4 away gets me to there, and then just joining it all in, obviously using a pencil for this one, and that'll be my triangle. I haven't drawn that in particularly neatly, there we go. Okay, not forgetting as well, though, you could have a line, it could say the line, I don't know, y equals 3, which would be across at y equals 3, which would be across here. There's another couple of lines that we could have as well. We could have this one, y equals x. The line y equals x is the diagonal line here where all the x and y coordinates are equal. So we could have that one as well where we have a diagonal. There's one more that we could have as well. Let's pick a different colour for this. We could have y equals negative x, which is very similar to the one above, but it's pointing in the opposite direction. And if I do that in blue as well, that's going down this way. So we could also have to reflect in a diagonal line. But again, you just follow the same process, counting diagonally. Right, okay, so something slightly different again. We've got the front elevation and plan of a solid are shown on the grid. And on the grid, draw the side elevation from the direction of the arrow. Okay, so we're looking at it from the front there, and again, thinking about the front elevation, we're looking at it from this angle here. Now again, thinking about the logics of the last question, it doesn't matter how wide it is for the moment, but the height of that from the front is going to be exactly the same height as it is over here. Okay, the height isn't going to change, so we can draw that in from base to the top there as being the same height. Now looking at the plan, we can see from the plan that it's only 2 squares wide. So from the front, we're only going to see 2 squares across. There we go, and that's the shape we're going to see. A rectangle that looks very similar to the last one. But there are a few little kinks here where the sort of depth of the shape changes primarily, and let's just get rid of some of these. We've got that one down the bottom, okay, so we want to make sure that that matches up as well. So we've got that one there, that's going to be in there, and we've got this one here, that's going to go in there, and there we go, that's what it's going to look like. Okay, it's almost like a little set of stairs. It'd be quite difficult to actually draw this, but imagining what it kind of looks like, I'll do my best. Let's have a think. It will go something like that. It's like a little set of staircases. I probably shouldn't have started drawing this because it's not going to look very good. But here we go. I'll try my best. It's going to look something like that. There you go, like a little set of steps, okay? And as you can see, this little step here is slightly higher up than the 2 below it, okay? As you can see from the diagram there, it's 2 squares up for that one rather than just 1 square up. So that's the shape that we're actually drawing. And obviously, if I sort of colour code this, look, we've got this face here that we're seeing as this one down the bottom. We've got the next one up, this face here that we're seeing here. And then we've got our final face, okay? In fact, let's do that in a different colour. We've got the final face there that we're seeing as this part here. Okay, so it does obviously help if you can kind of visualize it as a 3D shape, although it's not the easiest to do. But there you go, that's how you go about drawing this one. Okay, so there we go, that's that one, drawing our, what elevation were we drawing? We were drawing a side elevation, there we go, so that was how we draw our side elevation using our other elevations, and it can help to be able to draw that 3D shape before you actually go about drawing the elevation, okay? But if not, you can always think about the logic I just used there, making sure it was the same height, making sure it had the same width as the plan, and obviously just matching in any of those little changes of depth there with those lines and indicating those. But there we go. Oh dear, got rid of that, and right in the last step, there we go, put that back in. There we are, so let's have a look at our next question. Right, okay, so in this question we're actually gonna have to draw the 3D shape, okay? So we need to have a think about what this is actually gonna look like. So it says the diagram shows the plan, the front and the side elevation of a solid shape drawn on a centimetre grid. It says draw a sketch of the solid shape and give the dimensions of your solid on your shape. Dimensions of the solid on your shape, okay? So just be careful with that, because obviously giving the dimensions means we've got to put the lengths on. So we've got to put how many centimetres wide or high or whatever it is. Now looking at this, look, from above it's a circle, and then from the front and from the side it's a rectangle. And there is only one shape, and this is just about knowing your shapes really. There's only one shape that's a circle from the top and a rectangle from the side, and that is a cylinder. Okay, obviously when we draw a sketch of that, we don't see it as a circle as a sketch. It kind of looks a bit like an oval sort of shape. But then we have the bit coming down. I'm not drawing that very well, let's draw that line in again. There we are, and a slightly bit of a curved base there, and you could even put the sort of dotted base at the back that we can't see. But there we are, that's a cylinder, and if you can imagine looking from above, you would see that circle, but from the side there, if we sort of dropped our heads down and we were standing in front of it, we wouldn't see that circle on the top, we'd just see the big rectangle there from the front, the side, the back, the left, whatever side you stand on, you would see that rectangle. So finishing this off, obviously we've drawn a little sketch of it, we've just got to add in the dimensions. There's two dimensions we want to add. One is the width all the way across here, and if we have a look, that goes across 4 centimetres, it's on a centimetre grid, so that's going to be 4 centimetres there. And then we also want to draw the height in, and let's have a look at this rectangle over here. It was 1, 2, 3, 4, 5, there you are, it goes 5 centimetres up, so we'll also add that in as well, and that is 5 centimetres. Right, there we go. Well, that's how you draw one of these, obviously from a sketch. It does actually mean that you've got to know your shapes quite well. You can imagine there's probably a couple of other shapes that you could have. Thinking about like a cone, obviously the front and the side of a cone wouldn't be a rectangle, but we'd have a sort of, there we go, this sort of shape from the front and the side if it was a cone. Okay, you'd still have a circle from the top. You might actually have a point in the middle if it was a cone, because you'd see that little tip of the cone as well. But there's just another kind of shape that you can imagine looking above being a circle, could also have a little cone as well. But there we are, that's how we go about drawing one of those, and obviously just making sure you read the question carefully. Obviously when it says give the dimensions, you need to make sure that you actually add those on from the grid as well. But there we go, let's have a look at our last question. Looking at the size of the angle between this regular octagon and regular hexagon. So there's different ways that you can approach this, but we need to know what the angles inside a hexagon all add up to and what the angles inside an octagon add up to. There's different ways of doing this. You can do the 180 list rule, so you can keep adding 180, so 3 sides is 180, 4 sides is 360. 5 sides is 540, and you can keep doing it this way, or you can apply a bit of a formula. So I'm going to go for the formula, even though I've started writing this down, but that is an option there that you can use. So for 6 sides in a hexagon, we take away 2, so 6 take away 2, which is 4, and then 4 times 180 tells us the total amount of, oh, that should be a times sign, let's change that. 4 times 180 gives us the total amount of angles in a hexagon, which is 720. So all the angles inside a hexagon equal 720, and there are 6 equal angles in there. So if we divide that by 6, 720 divided by 6 gives us 120 degrees. So all of these angles in the hexagon are 120. Obviously we're concerned about this little area here in this question because we're trying to find the angle between them, but we've got the angle in the hexagon, and that's really important. When you see these words regular hexagon and regular octagon, always just work out the interior angle and label it all over the diagram. So moving on to the octagon, same process, 8 sides, take away 2 is 6, and then times that by 180. There you go, and 6 times 180, which is okay if you have a calculator. If not, you just have to work that out, but 6 times 180 is 1080. And again, it's got 8 equal angles, so if we divide that by 8, 1080 divided it by 8 gives us 135 degrees. And again, we can just label that all over the diagram. So 135, 135, and lots of these, but I'm concerned again with this little area here. So angles around a point equal 360, and at the moment we've got 2 of these angles, kind of like a jigsaw. So if we add these 2 together, 120 plus 135. At the moment we've got 255 degrees and we need it to add up to 360. So to finish that off, if we do 360 and take away that 255 that we've just worked out there, we get a missing angle of 105 degrees, and that's our final answer there, 105 degrees, which we could always label on the diagram as well, 105. And there we go. So whenever you see these questions where it says regular octagon, regular hexagon, okay, just spot these bits of language here, just work out their interior angles and label it all over the diagram. Working out the volume of a cuboid is quite nice and simple. I do like to do it in a particular way though, just so it's the same for all of these shapes where we have a constant cross section. So this cross section, I'm going to have a look at this front face just here. So I'm first going to just work out the area of that, which is 8 times 12. So 8 times 12 gives me 96, and that is the area of the cross section, 96 centimetres squared. And then to get the volume, we just times it by however far back the shape it goes, which is the same as that 14 back there. So times that by 14, 96 times 14 will give us our volume. So 96 times 14 is 1,344. And it's a volume, so we put centimetres cubed, and that's how you work out the volume there. That works for any shape. We've got a constant cross section. If you imagine, sometimes we have these triangular prisms, and sometimes we could even have a trapezium face prism there. Okay, anything with that constant cross section, you always work out the area of this front face to start with, the cross section, and times it by the distance it goes back. That same logic can be applied to a cylinder. So our cross section this time is a circle. So all we've got to do is work out the area of the circle, remembering area equals pi r squared. So working out the area of that circle, it's pi times 4 squared, which again is 16 pi. We can write that as a decimal. Now what I'm going to do is I'm just going to leave it as 16 pi for the moment, so we don't have any rounding errors here, but you can write it as a decimal at this point, but I'm just going to leave it as 16 pi. Now once you've got the area of the cross section, you just times it by how far it goes through the shape, which in this case is this 15. So all I've got to do is times that by 15. So 16 pi times 15, which comes out as 240 pi, which is also a decimal, so it just depends on how the question wants the answer here. So it's 240 pi. Now there are a few non-calculator questions, and again there's more of these on the higher, but two here that we really need to know, and that is sine 30 and cos 60. Now the value of sine 30 is 1/2, as is the value of cos 60. So they're both equal 1/2, and they're really good ones to make sure that you know for these non-calculator papers. Okay, so do remember those ones, sine 30 and cos 60, and they're both equal 1/2. And let's see how we can use that. So this question says, given that sine 30 is 1/2, which hopefully we know anyway, work out the length of AB, and AB is this side here. So let's label this triangle up. We've got the opposite, we've got the hypotenuse, which it's asking us to look for, and this is our adjacent again. Now again, we're not going to use the adjacent here, we're just going to use O and H. And if we remember our little formula, look, SOH has the O and the H in, and we're looking for the hypotenuse. There we go. So if we're looking for the hypotenuse, we cover up the H and we need to do O divided by S. So S is my sine 30, so if I was to do this on a calculator, I'd have to do 4, and I'd have to divide it by sine 30. Okay, but this question's actually told us that sine 30 equals 1/2, so actually what I'm doing is 4 divided by 1/2. I'll write that as a decimal, it makes it a little bit nicer to see, but 4 divided by 0.5. So actually it's just asking me to do a number sum there, which is 4 divided by 1/2, and if you divide by 1/2 it doubles the answer there, doubles the number. So 4 divided by 1/2 is 8, so my answer would be 8 centimetres. There we go. And of course that could go the other way around as well. I could have to do a times. So had it not given me this 4 here, maybe it had already told me that this was 8. Then instead I would do 8 times 1/2, doing S times H, so 8 times 1/2, and that would give me the 4 here that's been given as the opposite. So we could have it either way. Okay, so when we're looking at a pictogram, we really need to look at the key. So the key here on the right-hand side, which I'll just highlight, says that a circle represents 10 tins. And it says here that some tins of paint were sold on Monday, Tuesday, and on Wednesday. It then tells us that on Thursday, 60 tins were sold, and on Friday, 35 tins were sold, and it wants us to complete the pictogram. So for 60 tins, that's going to be 6 of those circles, as they represent 10 each. So we just draw 6 circles into our pictogram, nice and neat, and there we go, there's our 6. For 35 tins, we're going to have to use part of a circle, so we'll get the 3 circles in that represents 30, and then we just need to draw half a circle as best as you can, which is going to represent those 5. So obviously drawing that nice and neat, and you can probably do it a little bit better than me when you've actually got the paper in front of you. Now for part B, it says more tins were sold on Tuesday than on Monday. How many more tins? So we just need to count from the pictogram. So on Monday, there are 3 circles, that would be 30 tins. And on Tuesday, there are 4.5 circles, so that would be 45 tins. So in total, that's an additional 15. You can show you working out. That's 45, take away 30, which is going to equal 15 extra tins that are sold on Tuesday as opposed to Monday. And there we go, there's pictograms. Okay, so this question says Harry and Seamus recorded the number of minutes they spent revising last week. So the table shows some information and it wants us to draw a suitable diagram to show this information. There's a couple of options. We could do obviously we're going to be drawing a bar chart, but there are a couple of different bar charts that we could draw. Now, regardless of which option we're going to go for, we're going to have to scale the axes. And when it comes to one of these, I'd probably draw a dual bar chart where we have the bars next to each other. So if we have a look at this, we're just going to have a look at the information and identify which one of those is our largest number, and that is 40. So we're going to need to go up to at least 40 on the left hand side. So if we just go for 0, 10, 20, 30 and 40, and then just make sure that you label those 0, 10, 20, 30 and 40. And then we're going to want to label the axes there, and that is going to be minutes. So we'll just put here minutes to the side, and then we're going to go down the bottom. So to make sure that we can draw this correctly, we want to label the days. So we're going to go for Monday, Tuesday, Wednesday, Thursday, and just label them in. So for here, we're going to go for Monday, and let's just imagine we're going to have our bars kind of drawn side by side. So it's going to go about that much, so that would be Monday, and then we're going to leave a gap between those. So our next ones are going to go sort of here. We can just sort of label this in every 5 squares I'm counting, just to make sure that it's nice and neat, and hopefully this all fits. So that could be Monday there, we'll leave a gap, and then we'll have Tuesday here, leave a gap, Wednesday, leave a gap, and then we'll go for Thursday just over there, and we'll separate the Tuesday and the Thursday just like that. Okay, so that also needs labelling, so we'll put days underneath, and we'll just write that that's going to be the days down there. Now we just need to draw the bars in. So if we go for Harry first, and we'll do 35 for Harry. So if we draw a bar coming up, obviously just between 30 and 40, and that'd be 35, and then 10 for Seamus, and we'll draw that in. Now obviously we can't tell at the moment which one is Harry and which one is Seamus, so we're going to have to draw a key. So what I'm going to do is I'm just going to slightly shade in Harry's bars, and then I'm going to draw a little key, and we'll draw that at the end so we know we've got some space. So for Tuesday we're going to have 30 for Harry, and again I've left a gap, so now I've got my bar here for Harry. And then I'm going to do Seamus as well, which is going to be 20. And again, just going to shade in Harry's, and don't need to shade it in massively, just a little bit of shading. Next one is 25, so 25 for Harry. And there we go. Let's draw that across. There we go. And we're going to have 25 as well for Seamus. There we go. And I've not drawn that perfectly there. You could probably do this better when you have a ruler and a pencil. I'll try and make it as neat as I can, and then again shading in Harry's, and then we've got our last one here, which is 20 for Harry, and we've got 40 there for Seamus, and that was the largest out of all of them, so up to 40, and drawing that in nice and neat, not forgetting to shade Harry in. And then somewhere on your graph, or to the side of the graph, you're going to want to draw a key. I'm going to do it over the top of the graph just because I'm limited on my space, but I'd normally draw it to the side. In fact, I could probably fit it into the side, so I'm just going to draw a little box that's shaded in, and I'll just put Harry next to that. And then I'll just do my blank box. That's Seamus. There we go, and I'll just put the key above that just there. Right, there we go. So that is how we would go about drawing our bar charts. Now you could draw a different type of bar chart as well, where the bars are stacked on top of each other. That's fine to do. I would always go against drawing that if I had the option, because obviously if we do that, we're going to have to scale the numbers up a lot more because we have to look at their totals instead. So for example, we would have to scale Thursday up to the number 60 because we'd only go up to 20 for Harry and then an additional 40 on top for Seamus, but you could go about doing that as well, but obviously given the choice I would draw one of these bar charts. So there we go, that's how we go about drawing one of these bar charts. Okay, so reading from a stem and leaf, it says the speed of 27 cars, work out the median and work out the range. So to work out the median, I want to know which one's in the middle, and we can take quite a nice approach for this. We can just cross numbers off either side until we get to that middle number. So if there's 27, I'm going to cross off 10 from each side at least, so I can start to get from the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then going from the back, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'm just going to do one from each side until I get one in the middle. So 1 and 1, 2 and 2, 3 and 3, and I'm left with this one here. Don't forget the key though, it says 3-8 or 3 line 8 means 38. So that's next to the 5, so it's 5 and 6, which is 56. So the median there would be 56. Working out the range, we want to look at which one's the smallest and which one's the biggest. Let's have a look. If I get rid of some of my lines here, the smallest number there is 38, the biggest is 70. So to work out the range, which I'll do up here, so the range will just be 70 the biggest, take away 38 the smallest, which is 32 as my range there. Again, there's median and range from a stem and leaf. Okay, the table shows the probability of picking different colours. So we have red, blue, white and black, and it says the probability of white and black is the same, complete the table. So at the moment, we've got these two which add up to 0.7, and probabilities have to add up to 1. Now what we've got left over there is 0.3. I like to think of it as 0.30 because if they're both the same, we're going to have to halve that, and half of 30 is 15, so it's 0.15 for both of those, and now they add up to 1. Now for part B, it says that there are 60 counters in the bag. How many are white? Now if we look at the probability of white, which is over here, 0.15 is 15%. So really all this is asking us to do is to work out 15% of 60. And we can do that nice and easy. 10% is 6, 5% is half of that, which is 3, and add them both together and that's 9. Now part C here, you won't be given this at the same time as question B because we already know that there are 60 counters in the bag, but it says that there are 12 red counters and how many counters are now in the bag. So if we imagine this is a completely different question now, but it's saying that red counters here, which is 20%, is now 12 counters. So all that's actually saying is 20% equals 12 counters. Now that's okay, we can turn that back into 100% quite nice and easy. I could just times that by 5, but let's imagine it's not a nice percentage. I'd have to try and break it down to something which turns into 100. So we could divide it by 2, which would give us 10%, which is half of 12, which is 6, and then times that by 10 to get us back to 100%. Okay, again, you could actually just times 20% by 5, but I think that's quite nice just to break it down and build it back up. So 60 counters there would be in the bag. Okay, so here we've got 60 people, each took a driving test one day. 21 were women, 18 of the 60 people failed, 27 of the men passed their test, one of the men is chosen at random. What's the probability this man failed his test? Now this is a little bit nicer to draw a frequency tree because we only have two options here. We have men and women, and then whether they pass or fail. So the trees are actually a lot nicer when it's just the two. Well, let's have a look. We've got men and women, and then off each of those branches they either pass or fail. I'm just going to put P for pass and F for fail. There we go, and there's the tree. And there we go, so pass, fail. So if we go about filling in the information we've got then, we've got 60 people took a driving test, so 60 at the start. 21 were women, so 21 down here. 18 of the 60 people failed their test. So let's have a look. 18 of the 60 people failed their test. So we've got these two here in failed, and that has to add up to 18. So 18 of them are going to fail. We don't know whether it's men or women yet, but 18 failed. Then it says 27 of the men passed their test. So up the men, 27 passed. There we go, that's that one. Right, okay, so that's all the information that we've got. Now we know that there are 21 women, so we can work out how many men there are. They have to add up to 60, so that's going to be 39. There we go. And now we can work out this one just here, because it's got to be 39, we've got 27 in there already. So that is an extra 12, okay, just double check they add up to 39. Yes, they do. Now we can deal with this bit of information. Look, these two have to add up to 18. We've got the one of them there is 12, so this has to be 6. And then these two here have to add up to 21. So we've got 6 in that one at the moment. So that's an extra 15 there to make sure that adds up to 21. Now we can take the same approach as before. It says one of the men is chosen. Work out the probability that this man failed his test. So one of the men, so it's out of these 39, and 12 of them failed. So there we go, we've got 12 that failed out of the 39 men. There we go, and there's our probability. Okay, well done, you've made it to the end of the paper 1 revision. As I said at the start, don't forget to look at all of these topics in more depth, and don't forget obviously that you will have access to these documents. Hopefully by the time that some of you are watching this might already be live, but if you are one of the first people to watch this video, then they won't be live just yet, but you'll have them very soon. So obviously if that was useful and helpful, don't forget to subscribe, don't forget to like the video, and don't forget to check in the description for access to paper 2. So with that being said, I'll see you for the next one.